Alright, this is my second video on factoring polynomials by grouping. You should only watch this video if you already have a basic understanding of how to factor polynomials by grouping, or if you've watched my other video on factoring polynomials by grouping. So we're going to look at two examples. In each of those examples, we're going to work two different ways. So if we start with this right here, and we're looking at this trinomial, this is the first one that we're going to factor. The thing that we need to notice about this polynomial, there's a special characteristic about these three terms, and that special characteristic is that each term has a common factor of 2. 2 is the GCF. So one thing that we need to do is we need to start by factoring out that GCF. So it's kind of like you're dividing out that 2 or undistributing that 2 out of those three terms. So if we see that those terms have the GCF, we need to start by factoring that out first. And then what we're going to do is we're going to kind of factor the trinomial that's inside the parentheses kind of like it's its own problem. So we're going to kind of ignore the 2 for a while and just treat this like it's its own problem. So what I'm going to do now is I'm going to look for two numbers. And what I want is I want those two numbers to add up to that middle term of negative 8r. But I want those same two numbers that when I multiply them, they give me 15r squared. And if you're wondering where I get 15r squared, I get that because it's the product of the first and the last terms. If I multiply r squared by 15, I get this. So I'm thinking through this. I know that both my numbers will multiply to give me a positive, but they'll add to give me a negative. Well, if they multiply to give me a positive, that means they're either both positive or they could be both negative. So since they add to give me a negative, I know that both of these numbers must be negative. So I'm looking for two numbers that multiply to give me 15r squared. They're both negative, and they add to give me a negative 8r. Well, you can guess and check and play with the factors of 15 for a while, but you're going to end up by figuring out that these are your actual numbers, negative 3r and negative 5r. Those multiply to give you the 15r squared, and they also add to give you that negative 8r. And the reason that we're finding all those, if you've forgotten, is I'm going to bring down this other stuff, but what we do is we bring in those terms, and they replace that middle term. So instead of writing negative 8r, we're just going to write negative 3r minus 5r because it's equivalent to negative 8r. And the reason we do that is it allows us to group. And so I look at this group of terms, these two, or this binomial. I'm going to look at these as a binomial, and we're going to factor the GCF out of those. So I've still got my 2. I'm not forgetting about that 2. But the GCF of these two terms right here is an r. They both have an r in common. So we're going to factor out that r, leaving us with r minus 3. Then I'm going to do the same thing with these two terms right here. I'm going to find the GCF of those. And if I look, the GCF of those, it looks like is going to be a 5. And since this first term, this term on the left is a negative, I'm going to factor out a negative 5. And that's going to leave us with an r because negative 5r divided by negative 5 is r. And then 15 divided by that GCF of negative 5 leaves us with a negative 3. Now we can see that I've got a common factor right there. So I'm going to factor that r minus 3 out to the front, leaving me with r minus 5. And now we're done. This is the most factored form of this binomial, or excuse me, of this trinomial. 2 times r minus 3 times r minus 5, okay? So the only thing different about this today is that we need to look and recognize if there is a GCF in our trinomial, and if there is, we need to factor it out first. Now, we're going to next go over here to the right, and what we're going to do is we're going to do the same problem again. I'm going to factor 2r squared minus 16r plus 30. And let's say we get into a problem and we forget to check for a GCF. I forget to look for this 2 that's the GCF. Let's say I forget to see it, I forget to factor it out, and I just jump into this problem like a regular problem. Let's see what would happen in that case. Well, what I'd be looking for is I would be looking for two numbers that when I multiply them, they give me 60r squared. And just a reminder, the 60r squared comes from being the product of the first and the last terms. 30 times 2r squared is 60r squared. And those same two numbers, whenever I add them, they need to give me my middle term of negative 16r. Okay? If I do some thinking about this, I play around with my factors of 60, I'm going to eventually come to that it's going to be negative 10r and negative 6r. Those will multiply to give me a positive 60r squared, but those are also going to add together to give me a negative 16. And so the whole reason we do that process is because it allows us to come over here and allows us to break up that middle term of negative 16r into two different terms. And then I bring down my 30. So we kind of did some aside work, and the whole reason we do that is to learn how to break those up. Now, let's do our grouping. I've got two groups, so I'm looking at my first binomial. I'm looking for the GCF. It looks like they both have an r, but also looks like they both have a 2. So let's factor out a 2r. That'll leave me with the r minus 5 in the parentheses. And now let's look at our second binomial. I can look at those. It looks like a 6 would go into both of those. But also, once again, if this term on the left is negative, we're going to go ahead and factor out a negative. So I'm going to factor out a negative 6. And that's going to leave us with r minus 5. If you're wondering how I'm getting the minus 5, is you just got to remember, if I distribute this back in, I should end up with this, right? So I'm kind of thinking what numbers would go here so that if I multiplied them by negative 6, it would give me this. Negative 6 times r is negative 6r. Negative 6 times negative 5 is 30. The whole reason we do that is to create these this big expression with a common factor of r minus 5. Once I have that, I can factor that r minus 5 out to the front of my expression, leaving us with 2r minus 6. Now, what you might be noticing at this point is that our answer is not the same. It's close, but it's not the same. So where did we go wrong? Well, the issue is we haven't gone wrong. We just haven't finished the question. And so let me show you what we need to do. I'm going to reorder my two factors. I'm going to write 2r minus 6 first. I'm kind of running out of space down here. And r minus 5 second. We can reorder those because that's the commutative property right there. I'm just, taking that one and writing it there and taking that one and writing it there. So nothing special really. Now look what we've got right here in this. We have a common factor, don't we? That binomial in itself has a common factor. It has a 2. So let's factor the GCF out of that. If I factor a 2 out of that, we're left with r minus 3, and then I just bring down my r minus 5. Now we're done, okay? Now we see that we're going to get the same answer either way. So the moral of the story is this. If you have a trinomial that has a GCF, like our example up here, you can either do what we did over here and factor that GCF out first, and then just kind of ignore it, kind of keep it over to the side while we factor the trinomial that's left in our parentheses. If we don't see that GCF and factor it out first, when we get to the end, we need to make sure we're aware of the GCF in our final factor and factor it out there. As long as either at the first you notice the GCF or at the end you notice the GCF, you are going to be okay because you will identify, or you'll be able to make it into its most factored form. I was going to do an example, but this video is already 8.5 minutes, and videos longer than that are no fun to watch, so I'm just going to stop there.